Today we're going to solve proportions, which are two ratios or fractions set equal to each other. But we're going to use the cross product method, and I think we've talked about this. I'm going to review it with you again. A cross product means you're going, making a cross and making an X with what you're doing. Making an X with what you're doing like this, and you're multiplying product across and across, right? So we can do that to solve, this is a proportion, right? To solve proportions. 15 times 10 is a cross product. M times 25 is a cross product. All right? We keep this equal. That's the secret to all this. 15 times 10 is the same. This cross product is the same as 25m. All right? How we solve from here is like a missing number problem. 25 times what is 150? How do you find the missing factor? You divide the product by the known factor. Like that. All right? How many times does 25 fit in there? 6 times, I think. So 6 is m. And we can test that by sticking 6 in here. And if you divide 6 by 10, you'll get the same answer as 15 divided by 25. If you reduce 15 by 25 by... I don't know if I'll be able to do that. No, I won't. No. I can't get this exact, but they have the same ratio. And these quotients are equal, or the cross products, we find that this ratio is equal to this ratio. All right, so that's using the cross product method. They talk a lot about that in the book. I did example 1 for you. Slope, or rate of change, is sort of, to me, a non-related topic that they just figured, well, that was not too hard, so let's toss this in here too. It's important to understand the slope of a line, which would be like how steep, I guess, is a line, between two given points. How steep is this line? That is equal to, this is called the run. It's really hard to make these straight. The run, you go straight across from a point until you know you are right under an exact point here. And then you rise up. And the distance of this over the distance of this, that ratio, is your slope. A ratio of rise to run between any 2 points on a line. This is a positive slope because it's going uphill. And just think, would it be positive if you saw a graph for your bank account that looks like this? Yes. You want it to look like that. Positive, right? And to remember, this is a negative slope. Negative slope. It's a downhill slope, right? And while it would be fun to ride if it was a ski slope, you would not want a bank account graph to look like this. That would be negative, right? So there's a difference there. A negative slope. On this one, maybe the rise is 3 and the run is, 6 maybe. So rise over run is 1 over 2. But since it's negative, we know that one of these numbers is negative 2. In this case, let's say it is 1, 2, 3, 4. 1, 2, 3. So it's a 3 rise over a 4 run. That's a little bit steeper slope. And it is all positive, so we don't need this, but we could show that if we want. And the slope is 3/4. Okay? Maybe with me still? Hope so. They show more about how we find this slope, which is going to be the hardest part. Find 2 points, or even better, when they give us 2 points. What's the coordinates? What's the coordinates? You have to go over 4 and up 2 to get from this point to this point. Over 4, up 2. Rise of 2, run of 4 reduces to a half. 1/2 slope. In this case, we go over 2 and then up 4. So that's up is the rise, goes on top. Keep that straight. Rise is on top now. I know you think of the rise sort of like related to the y, because y-axis is up and down, and normally in coordinates the y comes second, but in slope you got to put rise on top. So it's just a little backwards maybe in a way from what you're used to, and that reduces to 2, or 2/1. Okay? So we're calculating slope, which is also the same as saying rate of change. Notice that the slope of something like this, it's so flat, we just call the slope is 0, because it comes out as the rise is nothing. And anything divided by, any 0 divided by anything is still 0. So the slope of a horizontal line is 0. And if we had a vertical line, the slope is so steep, we can't define it. We don't know. Undefined. Basically saying this is not a slope. It's something else entirely at this point, because you can't divide by 0. All right, rate of change means we're finding slope, basically. And they've got a graph for drive and basically speed, because it's time and distance. And they've even done the nice thing of making the dots. These dots represent different points in time. After 1 hour, after, 3 hours, and after, looks like 4 hours. All right. What's the average rate of change, miles per hour, over these 3 intervals? 0 to 1, 1 to 3, and 3 to 4. And since it is a constant rate, all these numbers are going to be the same. But just for the sake of working here, we start from 0, like it said, and we find rise over run. You could either think of it as the run is 1 and then the rise is 1, or we could go down 1, left 1, which would be like -1 over -1, because down is negative and back is negative, to get from the higher point to the lower point. And we know a negative divided by negative means it's a +1 slope. Or really, when we started with the rise, we saw it was 1, and then we went up 1. So in either case, this is a +1 slope. Rate of change means you're going to take then this over the slope, I think. Actually, no, I'm doing this wrong. It's not 1. This is not 1. This is 50, right? Because these are not going up 1, are they? These are going up 50. So it's a rise of 50 and a run of 1. So I'll show you a little bit better. New color. Let's do this again. The run this time is 3. That's easy, because we see it's 1, 2, 3 from 0. Oh, we're going from 1. So from 1 to 3 is 2, because 1, 2. That's the horizontal. Up and down. From here to here Okay, we did our 3 or our 2, and then to go up from there would be 50, 100, right? And that's going to reduce to 50 over 1. Then if we go from there, run of 1, because 3 to 4, and then a rise of 50, rise over run. Okay, so every time it was still 50 miles per hour. He's going at a rate of 50 miles per hour. What's the change of distance to time? It's 50. That's what speed is. It's kind of a silly problem. If a function is linear, the points are aligned in a line like this, then the slope between any 2 points is constant. All right, why don't you find the unknown using cross products? I want to see that work for B and D. B and D. And then let's do what I just said on slope. Looks like J. Do letter J. B, D, J today. Do your best.